Okay, here we are today again. I'm doing a little piece on some of the tools. You know, just about everybody that has done very much work on vehicles has found herself in a position where there were tools that you needed that you didn't have, or maybe there was a tool you didn't even know they made that you had a tendency to put together. And I have in prior presentations, I've shown you little tools I made for this, that, and the other. You know, and then some of the tools that were tools you could have bought on the tool truck. But just like I say, if you're in a situation where you need to do a job and you've got a bunch of them coming in there all at once, you know, you need to basically come up with some kind of a way to get the job done quicker. And you can save you some money if you can make a tool of your own that works just as good as the one that Lowell or somebody else makes. But a lot of the times the tools that they made, they got an inspiration from somebody that had made a tool and maybe sent them an idea or something like that. One of the examples of that was back in when we were doing a lot of the Power Stroke diesel stuff when I was at Ford. There was a issue that we had back when those in the 90s on the 7.3s, trying to figure out which of the cylinders was misfiring. It wasn't always as simple as it seemed like it should be. You know, like on the old spark plug wire vehicles, you pull a wire, or you disable the injectors, or even use your scan tool now to turn the cylinders off one at a time to do an impromptu power balance test, you know, before they had but back in the day, you know, when we didn't have any kind of scan tools or anything, and we might be working in the shop, didn't even have a scope, we would actually be able to pull in the plug wires and stuff to try to figure it out. On those Power Strokes, it was difficult to tell which cylinder was misfiring. So what I had come up with, I told the shop foreman and the service manager, I said, I think I can get a project box and put 8 toggle switches in there and get some of the valve covers, you know, the injectors and glow plugs, you know, plugged into they had a little small 9930 harness on the inside of the valve cover, and then on the outside of the valve cover, the wire harness from the engine controller plugged into that. And so I got some old valve cover gaskets, because we were going to replace them all the time, and used those connectors, and I made a harness to go on this, to come out of this box that you plugged in between the injector harness and the valve cover harness, so that these toggle switches, which were rated for 250 volts anyway, you know, Power Stroke injectors fire on 115 volts. But what I did was I took it so that we could flip those toggle switches and kill the injectors one at a time. Of course, you threw a passel of codes in there when you did that. That didn't matter. And so we were able to better tell which cylinder was misfiring that way. You know, and we had tried a lot of stuff. You could use you know, stuff on the manifold runners and all that. Of course, not a lot of people in those days had an FLIR camera, you know, like we have now. But we would do all kind of temperature measurements and everything else. Nothing's quite seemed to work. Well, I basically drew a schematic and an illustration of this thing, and I sent it off to Ford. And says, hey, did you ever think about making a tool that would cut the injectors off? You know, because I built one that we're using here at the shop, and it had really helped us. And so Ford basically sent me a letter back and says, no, we're not interested in any of that. Of course, you know, I had sent stuff in to the Best Ideas contest a few times anyway, and they won that thing 3 times. It was a $100 prize, and you get a little certificate. I'll show you some of those later on. But the point is, they came out with a box that did the same job the one I built did about a year later. And you might have seen it as a red box with 8 push buttons on it. Now theirs was slightly better designed than mine, because it would plug into that big bulk connector and it, you know, down there between the wire harness that came from the engine of the truck, that big square one, it would plug in there. And you basically had instructions to watch for your cubic millimeters of fuel to change. You know, if it didn't, whenever you mashed the button, the button where it changed the least was the one where the injector was skipping and all that anyway. But that was something I had done. There was another tool that I built using a EEC-IV ignition module, where you could take you could plug this thing in. I had a wire harness that had a module connector, and I had that thing wired to the 3 tangs on top of an ignition module. And I had a heat sink on the back of the ignition module, because that module gets really hot when it's firing a coil. And you could plug this thing in between the ignition module in the wire harness, and you could basically plug the wire harness from the vehicle into the module on the tool, and then the wires coming off the top of that module you go around here to the plug it into the module on the distributor, and it would start the vehicle if the module was the problem, because it would be getting the pip signal through that top wire on that, that little top lead on that connector. But the point is, I also added a little LED that would blink off and on if the profile ignition pickup, if the stator in the distributor was putting out good. And Hickok had a tester for this system, and I actually contacted Hickok and I said, Hickok, why don't you put one of these together and throw it in there with your tool? And they sat back and they said, well, we don't even know why we would need this. I actually seemed like I talked to them on the phone about it. And I said, well, your tool does just fine about telling you what's wrong, but if the module gets hot and the car quits out there somewhere, what's going to get you back to the shop? You plug this thing in, you got a bad module, and you can make it back to the shop. That's the smoothest way you can do this, and they blew that off, they never did come out with anything like that. Anyway, all of that stuff was of necessity. Now, a lot of the stuff we do, we actually will take bent or cut off wrenches. Just about everybody with a torch or a high-speed cutter or a grinder has ground or cut off a wrench to modify it to be better at doing a job that the regular wrench wouldn't do. Notched or filed screwdrivers, drill bits or bolts welded or brazed into sockets. One of the things that I ran into not long after I went over to work at the college is we had a Ford probe with a timing belt issue of some kind. Seemed like in the, and you might notice on these cars with engines in them, east-west orientation, the sideways engine in them, a lot of times you'll have about this much space to work with in between the car and the engine, and if you twist off a bolt that's important, then you need to drill that hole out and put a helicoil in it. You can't just get a whole big drill and put in there. So what I basically did was cut the end off of the right size drill bit to put a helicoil in, and then I brazed it into a socket. Now, brazing works better than welding, although if you had a MIG welder you might be able to do it, but the long and the short of it is the brazing seems to me to be better, and I've mentioned that before. So I brazed the drill bit in there because it was aluminum we were drilling into anyway, and we put that thing in a air ratchet and managed to drill through there. We put a helicoil in there and we fixed that vehicle without, with a minimal amount of trouble. And so basically a lot of times it's a spacing issue. I also showed you a little tool I made with a wrench and a big Torx head thing the other day. Notched bolts for thread chasers. My dad taught me that a long time ago. If you got some threads that are messed up and you don't have a thread chaser or a tap that size because it's a screwball thread or whatever, and you've got another bolt like that, sometimes you'll have extra bolts, from another job, or you dug out of your bolt bucket or whatever, and you can take your high-speed cutter or a file or something and cut slots in those threads down there at a sort of an angle so that you can get this thing started and it will chase those threads out. I've done that a bunch of times too. But you name it, I've done it. And then these electronic tools I've built. Well, this is a wrench that I modified one time. It's the 7/16, which is just like an 11 millimeter. And it was hard to get to bolt, and it seems to me like that was on some kind of a carburetor that we were having to work on, and there was a nut that you just absolutely, it was really hard to get onto it with anything. And I notched this down here so you could put a screwdriver in it and use it for your turning torque. Similarly, over at the college, we found ourselves without a tool to screw the inner tie rod ends loose from the rack on this Taurus, and that the wrench size is 1 5/16 in there on that particular Taurus we were working on. And so we were trying to get that to screw out there because we had a really bad worn out inner tie rod end. And we had a whole bunch of, when I went there was a whole bunch of different wrenches and stuff that from, sets of wrenches that had been bought down over the years that belonged to college. And I got an 1 5/16 wrench, and I heated it up red hot with a torch and bent it into a 90 so that I could reach up in there and stick it on that inner tie rod end, and then stick a big screwdriver in the box into that wrench and turn that thing. Well, we fought with that one. It didn't even want to turn that way. That was a big heavy deal we were doing. And so basically what I had to do is just put a little bit of heat on that into that tie rod end that screwed on the end of the rack. I didn't put enough heat on it to melt the seal in the rack, but I put enough heat on it that it had some Loctite on it that needed to be softened, and then it screwed off, you know, real easy. But I had modified that wrench, and that wrench is still in the toolbox over at college as far as I know, unless the new instructor's thrown it away. This one right here I created because we were having to remove and a lot of the oxygen sensors on these late 90s F-150s with the 5.4 in them, and we would there was that oxygen sensor was facing away from you. It was hard to get on it with much of anything. And I found out I notched that wrench, that 7/8 wrench, and I put this is a proto, you know, and I put it up on that oxygen sensor, and I'd hold it with one hand, and then I would use my big pry bar to pry against that to break it loose. And once I get it broke loose, I could always screw it out there on my fingers on those trucks. Well, the reason we were having to change those oxygen sensors was because the air conditioner evaporator drain was dripping on the oxygen sensors and ruining them. And after we replaced the oxygen sensor, or actually before I put the new one in there, we were supposed to take this particular piece of, it was basically a PCV closure hose. It was from some vehicle or another. They gave us the part number for it. And we were supposed to cut that plastic tube, and it was an elbow that would barely stretch over that evaporator drain outlet. And I had this thing I had built, and I should have took a picture of that too. That was an old pair of injector pulling pliers that nobody ever used for anything. And I drilled a hole in there and made it where I could stretch that thing and let it stay stretched for a while. And then I would put some silicone dielectric grease on it, and I would reach up there, you know, and put my screwdriver in it, hold it up in place, and roll it on there with my finger. And then I would angle that so that whenever the evaporator drain was dripping, it would come out of this tube I had put on there and drip somewhere else besides dripping on the oxygen sensor. They straightened it out from the factory later on, but that was a program that we had to do, and I built that. I used this wrench right here for the specific purpose of that. If you've got more than one wrench this size, or you got 2 or 3 of them the same, you know, that are alike, and something like I do in my box, I've got all different kinds of brands of wrenches that I bought down through the years, you know. But anyway, that one there was a real handy, and never failed to break one of them oxygen sensors loose. All right, this one right here is a tool that I created, speaking of oxygen sensors, with this long, I put this long screwdriver bit here. It's actually a piece of tubing that I put in that screwdriver handle. And I brazed this on the end of that thing, which was a piece of something that came, it wasn't a socket, but it was a circular thing that I cut like that. So basically what I would do with this, when I was plugging in an oxygen sensor that was way up in there, you know, where the pigtail that's coming off the harness is dangling up in there, and the transmission is so close to the transmission tunnel that you absolutely cannot get your hand up in there, you know, unless you're a skinny little girl, and every now and then a young boy or a skinny girl could get their hand up in there. But if it was hot, that was aggravating too. If you're going to burn your hand if you're trying to put it up. But anyway, long and short of it is, I took that thing and made this, and I would reach up in there with this end of it, and I would hook it around the top side of that harness connector and pull it down here to me, and then I could just go click and plug that oxygen sensor in. It worked really smooth. It worked well enough, and I used it enough that I built one like it when I was at the college, so we could use it for the same reason over there. And there was other things I found that I could do with this tool too. You know, it's really something how when you build a tool, you come up with other uses for it that you didn't anticipate later on. This right here was a tool that I had actually put together that actually came with the injector cleaning machine. But I built this tool right here for stopping up these return lines on the fuel rail when I was cleaning injectors. Now this right here was one of these spring lock couplers that was air conditioning, and I got rid of the spring lock coupling flange and all that, and I used this to hook the transmission fluid exchange machine up to this 2004 Mercedes. It belonged to the president of the college, and he was telling me whenever he originally bought the car, used it was supposed to have lifetime transmission fluid. I mentioned that the other day. But he said that it was shifting wrong or it was acting up. I don't remember what he said the problem was. I said, well, let's give me the right fluid for it from Mercedes, and we'll do a full fluid exchange. And when we did, it took care of his problem. Anyway, I had to build this. There was a whole bunch of adapters that came with that forget the brand of that darn thing. Anyway, that transmission flush machine, and I couldn't find an adapter that would work with his Mercedes, so I had to fabricate this one, and it worked really good. You know, sometimes you got to build stuff. I don't know how many homemade test slats I built just for the fun of it. You know, I would drill, I would cut the end off of this and put a little threaded bushing in it, and I would cut threads in here so you could screw that cap off and back on and drill a hole in it, and I would go all the way down through this with a drill. And when I got to where I had exposed this metal piece down there, I would get a bulb, and I'd get me a, you know, build me a little spring or something to put on it like you used to see on regular test slat, and I'd shove that down in there, and I put a little dielectric grease on the end of the bulb that was going against the screwdriver handle. Of course, you had to scratch on that real good to make sure it had a nice even contact. And then I would put this particular one here, had a very, very long cord on it. It must have been 10 or 12 feet long. Of course, a lot of the time, if you're going to work on something and you want to have a good power and ground source, you know, I've got those logic probe that's got a long cord with it and all that kind of thing. I got one of those out in the truck. They're real handy, and I use those for a long time. You can actually feed power and ground into something with those logic probes too, and I've done that before. Of course, if you got students using it, they're eventually going to fool around and burn the thing up. You know, I had them do that. I don't want it belong to the college, but I bought this one over here. Seemed to me like I found it at a pawn shop. Other people didn't know what to do with it, and I bought it for nearly nothing. And it was brand new. It had never been used. But anyway, I had built these test slats for myself and for other people, and I would actually buy this floppy cord. You could get it at Radio Shack back in the day. It was test lead cord, and it had that silver colored wire on the inside of it. It was kind of similar to fusible link wire. Anyway, I built one of those things for a guy named Marvin Lampley that worked with me at the Ford place, and nearly 20 years after I built him that, I went back over there to visit one day, and he says, "Come here, I want to show you something." And he pulled this thing, the test light. It's not one, it was one similar to that I made out of a Craftsman screwdriver. He pulled it out of his toolbox. I'd sharpened the tip, you know, so you could use it. And whenever he pulled it out of his toolbox, he hooked it up to a battery and showed me it still worked after all that time. He'd never even had to change a bulb in it, and he used it just about every day. This was a little play pretty I made, just fiddling around one day. I had this button I had bought from Radio Shack, and I took the guts out of this relay, and I put that button on there so that I could plug this relay in where a regular ISO relay went. Of course, you got to make sure, you look at the side of it, you got to make sure that the 30 terminal and the 85 and the 86 are in the same spot now, because there's a whole bunch of different relays that have the same pinout as these ISO relays. And you know, on a BMW, you may find them with any kind of configuration is incredible, and some of these other cars too. But anyway, that thing right there, I would plug it in, and I could actually mash that button and close whatever circuit that relay was operating. Now, I will tell you, it wouldn't carry a whole lot of amps because these are a little lightweight switch. But it was a way you could test the relay circuits, you know, as far as the secondary circuits, which would be your load carrying circuits. You could press it just briefly and let it. Now, if you wanted to get slick about that, you could put a little LED on there and hook it up to the coil terminals and let it tell you if there was power and ground there when the thing's supposed to be energized. I mean, there's all kinds of stuff you can do. Necessity's a mother of invention. You just keep working with stuff and think, well, if I had this, I could do that. Now, there's tools you can buy. There's dandy little relay test tools that you can buy, you know, where they got a little, you pull the relay out, you plug this thing in, it's got little naked terminals, you plug the relay back into it, and it just puts them out where you can get to them. The thing about it is they charge you ever-loving crap out of you for those things, and some of the stuff, if you can build it yourself, you might save yourself a little bit of money. This right here is a box that I built for some reason or another. I used an old lock and unlock switch, and I had a plus and minus switch. I think I built this to check ISC motors and shock, actuators or something. But anyway, I built a lot of these boxes, and I really enjoyed putting all these little LEDs in there and wiring up. And you got to put a resistor in series with an LED, or it'll burn out as soon as it sees 12 volts. So make sure you put a resistor in between there if you're going to wire something like that up. But anyway, that's an example of that's in my toolbox out there. Well, what was funny to me was when I had all of these in one little plastic clamshell box, a lot of these tools I'm showing you. And when I opened it up, I looked at that and I said, I remember building that, but I don't remember when I built it. There was another one I had that was had a power window switch on it that I got out of Jeep Cherokee, you know, an old one, and I had that thing on there, and it was a rocker switch, and I had it wired up so I could use it to operate idle speed control motors or any kind of motor, you know, that was a polarity reversal type circuit, and it worked real smooth for that. And then finally one day that switch burned out, and I said, well, I'm not going to be able to buy another. I don't want to pay $18 for another switch. Well, back in those days when we were doing a lot of pre-delivery work on these Eagle medallions, there was a relay that you were supposed to remove from those Eagle medallions and replace it with a jumper, which was a strange thing, I thought. But I had a gaggle of those relays. I think I've still got some of them. They were just a simple little ISO relay. I had a bunch of those things in my toolbox. I wasn't going to throw a relay away, you know. And we were supposed to pull it out anyway and never put it back. It was a crazy thing. If you did any work on those old Eagle medallions they only made for a couple of years, you might have seen those. The wiring on those Eagle medallions was weird too, because they would have wires running from one end of the car to the other that were all the same color, and the only way you were supposed to tell which wire was which on each end was they'd have a little bit of paint smeared on the wire right by the connector on each end, that yellow, red, green, whatever, and you could scratch that paint off with your fingers. You know what kind of a disaster that was? Anyhow, long and short of it was, I took, down there I was eating by myself at the steakhouse for lunch one day at the mall, and I was trying to figure out what to do so I could make my little polarity reversal box work again. And I usually kept a bunch of these here, you know, regular Radio Shack buttons like the one I had on that relay I showed you earlier, and some smaller ones too. But I realized as I drew a circuit, never had seen this before. I drew two relays wired together so that I could put them inside that box, and I could basically energize one relay and then the other relay, and it would do a polarity reversal. Since then I was noticing that Chrysler and Ford, some other people use relays in that same kind of wiring configuration for power door locks and stuff, you know. But anyhow, I built a box with two relays, two buttons, and it would do the same job, and it would also carry more of a load because those relays are really strong. Anyway, long and short of it is, here's the airbag for some of the airbag systems I had. I don't remember if the dummy loads that Ford sent us were one of them got lost or whatever, or if I just wanted to have one of my own. But I took a 2 ohm resistor and I put it in here, and I actually put this, and I would plug that in, unplug the airbag, plug this in, and that way the system would think it had an airbag in there, you know, from, you know, supplemental restraint, and so I could troubleshoot the system without blowing the thing up in my face or whatever. And so that's a nifty little tool. Then finding the connector that was the right configuration was the big deal. I had a whole bucket full of connectors, and every now and then I would find one like that I would decide to build me a little tool like that and use. This one right here, you might remember on some of the two-wheel ABS systems on the Fords, they had within the RABS valve, there was, it knew if you had unplugged the valve or not, or if the wires were broke, because there was an 18,000 ohm resistor inside the valve, and there was basically a voltage that was being fed by the ABS module down to that valve, and it was supposed to be at a certain voltage deflection level, and I had all that written down. It seemed like it was 1.9 volts that it was looking for. If you unplugged it, it would go to 5 volts. If it was shorted, it would go to 0. In either way, you would get a code. Well, if I thought there might be something wrong with that 18,000 ohm resistor inside that RABS valve, because I think it was a code 4, I think. Can't remember. But anyway, I would unplug the RABS valve and I would plug in this little connector, and if that code 4 went away because I had an 18,000 ohm resistor in there, then I knew that RABS valve was at fault. And I would, you know, this was a connector that would fit and all that. Pause right here. There was I worked on those rear wheel anti-lock brake systems for a long time, and they're not that tricky if you understand how they work and how they're wired up. There are some little nuances about them, and I've made some videos about them, about one particular one before that I thought had an interesting problem. But one of the things that I was amazed, I was training this guy named Mark, and and the experience that I had with these two-wheel anti-lock brake systems were that you never had a bad ABS module. It was always something else. And you know, because I had actually made the mistake of, you know, plugging in a new module a time or two when I thought that's what it was, and it turned out what it was. So I told him, I says, don't ever think that you're just going to plug in a module and fix one of these, because it's always going to be something else. Every time I've ever fixed one, it's always been something besides a module. I don't know that I had ever seen a bad module ever, and so I had, you know how we're so prone back in the early days of electronics. We just always wanted to blame it on the black box and plug another one in, and about 8 times out of 10 that wasn't what it was, and we wound up either spending money that didn't need to be spent or whatever. But the crazy thing about this guy, whenever he started doing his own work, it seemed to me like every one of those things that he got had a bad module, and I had not found a single one with a bad module. That was kind of like whenever I kept seeing the bad number 4 spark plugs on those late 90s Explorers when the single overhead cam Explorer first came out. I would see number 4 spark plug would be, you know, cutting out under load, and it was, I don't know why it was always number 4. It was the number 4 over and over and over again. I kept seeing one after another. Well, I mentioned that to Donnie, and he said, I hadn't seen any of those. I don't know what you're talking about. And there ain't no way it's always going to be number 4. And I said, well, it was every time I've seen it. And, you know, the transmission mechanic yelled over here, and he goes, hey, I got an Explorer over here. They said it had a transmission problem. And I'm driving, and I'm feeling an engine skip. And I looked at it, and it was the right year model. And I said, throw a number 4 spark plug in there and see if that fixes it. You know, and Donnie just looked at me like he thought I was an idiot. And that guy said, okay. And so he yelled back over a while ago, and he gave me a thumbs up. He goes, that took care of it, you know. And so Donnie finally got his first one that was skipping, and he found out it was a number 4 spark plug for him too. But they had us replace all the spark plugs in those. They had resistor plugs in them, and they had us put suppressor plugs in all of those vehicles, because apparently it was some kind. But why it was always number 4, I had no idea, and I can't explain that. You know, I always like to be able to explain everything. There's some things I just can't explain. This one right here was, I would take and make little adapter connectors like this. I could connect a Dodge ignition coil to a Ford system that way for test purposes, because I had a good Dodge ignition coil in my box of tricks. And of course that Dodge ignition coil was one of those kind of like to fail on those, you know, those 90s Jeep Grand Cherokees. But I had a good one in there for a test, and I wanted to use it when you know, a coil is a coil. If you wire up a coil, now it's a little different if you've got a cop coil that's got the circuits built into the coil. They have to be triggered such and such a way and all that kind of thing. But if it's a 2-wire ignition coil, it doesn't matter if it fits a Briggs & Stratton. As a matter of fact, I've taken Briggs & Stratton engine coils and started my wife's car with it when she was driving a Tempo to make sure that the coil was okay. Now that works if the Briggs & Stratton coil is one of the old ones that had the points on the shaft. If it's one of the Briggs & Stratton coils that's got the little electronic ignition trigger that's built into the coil, it may start your car, but that little electronic ignition trigger can be bad. But the long and the short of it is, a coil is a coil. And it doesn't matter if it's a coil pack, like off of a Kia, and you're using it and you're firing something, you know, you can, if you got something that'll trigger a coil, it'll do it. There used to be a little box you could, you know, you build with a button and to replace your points, and or maybe a toggle switch and a capacitor, you know, a condenser out of the distributor, and you could test coils that way. Something else you could do is on your GM, if you're looking at ignition issues with an HEI. Now HEI is ancient history now, and I understand that, but a lot of people still fool with it. Of course, if anybody's driving something that old, a lot of times they'll have MSD ignition on it. Long and short of it, you can take a soldering iron, plug it into the wall, and hold it down close to the distributor, and it'll fire the coil like that. You can also get a transformer like out of an old radio, or one of those little 12-volt transformers that plug into the wall. It's got 120 volts, and it puts out a 12-volt, you know, sine wave. You can actually connect that to the pickup coil wires on an ignition coil. On an ignition module, and the ignition module will fire the coil with a steady buzz the whole time, which is pretty cool. I used to like to play around with that kind of stuff. This right here is I got kind of wacky here. This was a box that was I took off of something I can't remember what it was, but I took all the electronic guts out of this box right here, or I don't remember the vacuum reservoir, whatever it was. You know, when I see a plastic box, I'm gonna think about, hey, what can I do with that? You know, and so I put these 2 connectors on it, and I hooked them up so that, of course, you check one relay or another relay. This is the Ford style relay or the ISO, standard ISO. You know. And I had 2 indicator lights on here that would check the normally closed and the normally open contacts. All you had to do was hook it up to the battery, plug in your relay, mash the button. Now on the side of the box, on the side of this, I put a note that said, this little light bulb is not sufficient to check the load carrying capacity of a relay if it's running something like a cooling fan or a fuel pump, because it may turn this light on but yet drop enough voltage under load that it won't. So this wasn't really a reliable way to test a relay, other than the fact, you know, if you could hear it click and see the lights come on, you know, that it would swap from one light to the other when you mash this little red button here. And that was just something I threw together just for the fun of it. You know, and I don't know if you've ever done stuff like that. You can build stuff just for the fun of it and just see what it is that you know, see, can I build this and make it work? But the problem I had with this little box that I've still got out there in my toolbox, I went out and dug it out to take a picture of it yesterday to put it on here, was that this was not what I would call a go, no-go test. This was a test that might work. I mean, that would, it might tell you what was wrong, but it might not. Perfectly normal not to trust it. And nowadays, you know, in this crazy world where the people, and these, some of this, whenever like computers took hold on vehicles, a lot of your folks would, your instructors would say, never use a test light on any car unless it's an LED test light or a logic probe, or you'll burn up the engine controller. And that was a bunch of nonsense. If you know what you're doing, you know what to check and what not to check with a test light. And you're not going to just go stabbing in wires and looking there. You know what's supposed to have current. Furthermore, if you go to some of these real classes that they have at places like KZ Vision, the first thing they're going to tell you is you need to have a load, like a headlight bulb or something, that's strong enough to make sure that the ground you're checking will carry that load, rather than just checking it with a meter, which will lie to you through its teeth. Or you can, if you're checking it with even a 1/4 amp, you know, low impedance test lamp bulb, only has about a 1/4 of an amp and it pulls. You basically need, you know, I saw one box that they built up there that one of these guys had showed, one of the instructors, it had 6 stoplight bulbs in it. And that way you could take some of the bulbs out if you didn't want it pulling quite so many amps. But if it would pull all 6 of those stoplight bulbs, that ground would pull just about anything else you wanted to pull, because a stoplight bulb, you know, pulls about 2.5 amps. And if you multiply that times 6, well, do the math. That's how many amps you're pulling. Or you can get one headlight bulb, but if you're using a halogen bulb, it needs to be in some kind of a bottle or something, so that you won't be touching the envelope or scratching it, having the halogen gas make it go, psh, you know, blow up all over the place. And so I actually built something like that at the college for checking loaded circuits and all that. All right, this one here was a harness that I built whenever I was an adapter harness I built to use with another tool that I had when I was testing components on different year models. You know, sometimes you'd have the square and then you'd have the round. I could basically go from one to the other on that kind of thing. Or, you know, anyway, there's all kinds of little harnesses you can build. If you've got the connectors, you know, that's half the battle. This right here is I had these 2 boxes. This one here was really unnecessary, but I just built it for the fun of it. It had a 9-volt battery in it. And the other box, which I left at the college, I wish I brought it home with me, it had a 9-volt battery in it too. And one of the things I wanted to do was this is an emitter right here, and that other box had a detector in it, and there was a little LED that it would close the circuit to that LED if it got a signal. So you could basically take this little green light that was shining in your face, and you could shoot this with a remote, and that remote that little detector diode would pick up that signal, and it would turn on that LED. It would beep, it would buzz a little code. And I was thinking, you know, I could get fix this little box so I could hook an oscilloscope up to it, and then whenever that little signal came out, I could basically look at the code on that. I never got around to doing that, but it was something I thought about doing. But anyway, the wacky thing about that is that was back when Jeeps had infrared remote keyless entry remotes, and the receiver was up there in the dome light area. And that was back in the late 80s, you know, whenever keyless entry first started coming out. And so here's the other thing you can do. If you've got a remote and you want to see if that remote is working, You know, in other words, if you want to see if the infrared output is working, I wish I had one in here with me right now. I'd show you that. I don't have one here, I don't think. Wait a minute. Yeah, this one here is one right here. This is for my fan. All right, I want you to watch that right there. See that? Can you see it? See that? You can see that. Now, I cannot see that with my naked eye, but every button you push is going to put out a code, and your camera can see that when your eyeball can't. So if you want to know if this is putting out, or even if you want to know if the battery's dead, if you punch that button, you know, you're going to see that thing light. And that was a trick that I learned by accident, making videos and using a remote to operate the recorder. Anyway, I built this little box so when you mash that button, it would just put an infrared signal out. I didn't ever have any. I built that to test the other box with, and I still have that in there, you know. All right, it's always a good idea to have some connectors, these weather pack connectors right here. When I wanted to fix weather pack wire harnesses, I had these, and I had the other version, the female side of this connector too. And then I had the little tool to reach in there and take these out of there, and I could replace these with exactly the right terminals. Well, there was another thing I used these for too. There's the part number for that in case you want to see it. It's probably been updated by now, 1201-4836. That's the Delco part number for those weather pack connectors, as if anybody still needed that. But these Grand Wagoneers had a module just like a Motorcraft module on it. That's what it looked like. And it had connectors. It was a Motorcraft style module, Duraspark looking, with GM weather pack connectors on it. And I didn't like this module because it was some cheap, crappy version and it would fail. And so I said, well, I'm going to upgrade this thing. When I get ready, you know, if I got one of these that came in and had a bad module on it, then I'd say, you know, I want to put a Motorcraft module right there. And so what I would do, and that's what those connectors looked like, you know, and they had the same connectors that I showed you in the cardboard box. Except I think these were the female version of it, but I had a box of them too, and I've got it out there now. And I would take a Duraspark module, the really good Motorcraft one, and of course I have actually seen online, you can see where people have taken this and gutted it and put a GM HEI module in there to do the same job, you know. But anyway, long and the short of it is, I would cut these wires right here, and I would take and I would put those, I would solder those other terminals like you were seeing in this box earlier, these terminals here, the female version of those in there, and I would make what looked like a factory module that had these kind of connectors on a module like this. And then when I put that on there, they were good to go, and then they never had the problem again, because this was a quality box, and that other one was a cheap aftermarket kind of a box that didn't even have a name brand on it. And I guess they probably commissioned somebody to do that. But anyway, now I had back in 1983, 84, whatever it was, I was working at Lincoln. We were doing a lot of electronic engine control 3, you know, the EEC-IV. It had the funky 2-port barometric pressure sensor on it that actually had a barometric port, and it had a vacuum port going over there. Big, ugly looking stupid thing with, right here, a picture of it. I've talked about it earlier in another video. I built me a box. There was a little connector, and that little connector was just hanging there. Ford never built anything, as far as I know, to plug into that, but they had it there where you could access it. But it basically was wired to your tab and your TAD. And whenever your tab and your TAD, you would put it in self-test by putting 10 inches of vacuum on that barometric port. That would put the system in self-test. And I had 4 lights on there. I went and bought a project box from Radio Shack, and I could watch those lights, and they would go this way, that way, this way, then they would both switch together, and then they would start giving you codes. And that's the code chart right there. You had a whopping 12 codes on that EEC-IV system. And you can see what the codes were here on that. But that was this was the EEC-IV box. And I built this little box right here for that. Now we had a little star tester, they call it, self-test automatic readout box, that I didn't really like that much. Because I built my own just because I like building stuff, and this had this little connector where I could plug it in, and it would go out here, and You notice self-test outputs here, signal return, which is ground from the computer, is here. Your fuel pump relay coil's there, and I used to ground that and energize the fuel pump if I wanted to run the pump. This is your self-test input. I didn't mark that one on this schematic, but this was a 5 volts, and when this 5 volts shorted the ground, you notice, then this right here would start. This was the same one that when they finally started putting check engine lights on Fords in 1988. This was the same leg that went to the check engine light that flashed it. All right, and so I had this thing hooked up to there was power on the vehicle battery, you know, I just put it in here. There was power going to this side, and then whenever it would flash, that buzzer and that light would go beep, 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 you know, it would flash out my codes. Of course, you had to be watching, you had to count them and all that. If you happen to blink your eyes, the buzzer would, you know, keep you where you wouldn't miss a number. Of course, when the way you clear the codes on one of these is after it gets through putting out the codes, you're supposed to take it out of self-test. When I'd latch that button, that's when it would ground this, and then this light and that buzzer would start flashing those codes out. That really worked pretty smooth. I enjoyed that. Now here's a little anti-theft story that I've told before, but I made a new schematic of it. The theft alarm control unit on this car was over here. Where the story on this car was, it was a brand new car, still on the lot. Ever so often, the horn would honk for 3 minutes and the lights would flash for 3 minutes, and then it would shut up for the rest of the day. And ever so often it would just do this without warning. It didn't matter where it was or what was going on, it might do that. They couldn't sell the car like that because they knew that they wound up with a buyback or, you know, disgruntled customers and all that. So they gave me this brand spanking new car. I said, find out what's wrong with this, see if you can get it straightened out. And I realized that the only way, this is a 90 model, okay? And it says the only way I'm ever going to be able to do this is I got to figure out a way to make it take an intermittent and store what the failure was. Okay, so here's the wiring was. You had a driver's door, passenger door, hood, and rear hatch. These were grounding switches, and whenever you open the driver's door, it would basically allow that to ground, right? In other words, when you close the driver's door, this was an open. Same here, hood, rear hatch. 4 inputs. The outputs were the horn and the lights. Other stuff hooked to this too, but for simplicity purpose I did that. So I said, well, what if I took a Radio Shack box and some really, really weak fuses, like 1/4 of an amp, 2/10 of an amp fuses, and little bitty weak fuses, and I built me a little box here, and I built that box, it looked just like that, but I wired it up so that it was back probing at the module each one of these 4 wires. And so then I put a little LED, all these little LEDs are hooked to the same ground. I might have hooked to battery ground, whatever, but anyway, all of these were burning all the time as long as these fuses weren't blown. Well, notice there's battery going in here, and anything that grounds any of these fuses is going to wind up blowing whichever fuse that was grounded. And so I left this thing parked in the shop, and I left, and I went home. There were some guys that were working late that night, and I said, y'all don't touch this car. If its burglar alarm goes off, I don't care if it beeps until it shuts down or until it runs the battery down. Just leave it alone. Don't walk over here and try to do anything, because I got this box laying in the seat with these 4 red lights burning, and I got them all labeled, you know, which one is driver door, passenger door, hood, and rear hatch. A little box right there. And so one of them, when I came into work the next morning and punched in, one of them said, hey, I was here last night and that thing lit off, you know, it's in my service bay. And it did that for about 3 minutes, and then it shut off, and I went over there, and the light that was going to the rear hatch was out. They had blown that fuse, so, I'm sorry, I lied, the hood, not the rear hatch. The hood one had actually blown its fuse, and that hood one's light was out. I said, okay, now I know which one of these legs is intermittently shorted to ground. It's triggering this to make somebody think they're opening the hood. And so what I did was I ran another wire. I cut the wire out that was shorting the ground. I cut it out, you know, at the switch, and I cut it out at the unit, and I ran a brand new wire. Well, actually I cut it out, yeah, right here at the switch, right, and I ran a brand new wire. The wire on the car ran across the hood switch was on the passenger side, right there by the fender, and the wire ran all the way across the radiator support, all the way back down the driver's side fender, into the car, all the way across the dash over there to the stupid module. Well, I wasn't going to play that game. There was a harness that was going right in there through a rubber grommet, and I took and peeled back the tape on that harness and opened up the loom on it, and I fed a new wire from this switch straight in there to that module that was only about this long. I mean, about probably 3.5, 4 feet long, instead of going all the way around Robin Hood's barn to get there. And I fixed that sucker. But it was this little box. I went to Radio Shack, and at my own expense, I built this, you know, so I could figure out what was going on. And so that was a pretty handy rig. Now we had this Escort 4 EAT transmission. The transmission went to shift right. Kevin rebuilt it. It still didn't work right. He asked me for some help. This Ford Probe, I remember, had a similar transmission, but the Ford Probe had a special diagnostic box with LED lights on it for all the shift solenoids and everything, but it wouldn't work on this Escort because the Ford Probe had a different setup, different connectors and all that kind of stuff. And so I said, well, I think I could probably build a box that would do the same thing. Now this is the shift. To start with, you got to have the shift, the solenoid chart for this. Now I've doctored this one up, you know, with the ones in red that are on at various different year ranges and all this kind of thing. You have to know this information before you even build a box and try to use it like that. So you got to gather some data. All right, and so this is how this transmission was wired up. You know, pin 11 goes to shift solenoid 1, pin 51 goes to shift solenoid 2, and pin 53 went to shift solenoid 3, and then finally pin 57 went to that one there, or 56, I'm sorry, went to the lockup. These were the 4 that I was concerned about. Now you might notice this was kind of like a Nissan. If you've ever fooled with any of these Nissans or some of these, we're always expecting to see solenoids receiving power, and then the computer will ground them. Well, in this particular case, the computer was sending power to solenoids that were hardwired to ground. You might notice these solenoids are hardwired to ground, and power comes to them. That's how those were wired up. Interestingly enough, the Ford air suspension systems were fixed the same way, and I could use this same box to look at the air suspension system stuff. On the ones. But anyway, so this is the box I built for that. 4 little LEDs, grounded, and they were tapped into these wires right here, so that whatever solenoid was on, I would know it. Now you got to remember, this was 1994. There wasn't any OBD2. The scan tool PIDs weren't really that great on this. And so this was the patterns you were looking for. In neutral, you should see that one on. In first gear, you should see, you know, you'd think they would have designed it so that whenever you shifted from first to second, the first LED would come on. When it shifted from second to third, the second would come on. And from third to fourth, that ain't the way it works. They're all over the map. They just do look at that. First gear, these SS2 and SS3 are energized. Second gear, 1, 2, and 3 are energized. Third gear, 1's energized. Third gear lockup, 1 and torque converter clutch are locked up. Fourth gear is 1 and 3, and fourth gear lockup is 1, 3, and torque converter clutch. Anyway, this box led us to the fact that he had a bad engine controller after he'd already rebuilt the transmission. But how many times do you expect a bad engine controller to make a transmission shift go crazy? I mean, that was just, but that box cost about $40 to build, and the transmission mechanic paid me to build it for him, but it led us to the problem. That's the whole point. And there wasn't a box that Ford built that did this. This right here is the best ideas contest thing. This was a lot of fun. I would actually get these, this was in October 1991, February 5th, 92, and April 24th, 92. And every time I got one of these, I got one of these plaques and $100. Now one time, the last one I got the plaque, but I didn't get the money. And so if you might notice that the vice president of general manager of parts and service was a guy named Tom Wagner. And one morning before I left for work, I opened the box that came from Ford, and it didn't have a check in there for $100, which I was expecting. So I called the Ford Parts and Service Division because I had their number, and Tom Wagner answered the phone. And I says, okay. I didn't know who he was at the time. And I told him, I said, hey, I got this thing, but I didn't get a check. He, well, that's the most important part. I said, yeah. He said, well, I'll tell you what, Ed. He said, give me the number of the dealership, and I'll have J.P. King, he's the guy that signed all the recalls, I'll have him call you at the dealership. And so I just said, okay. So he called me at the dealership when I got to the dealership, and because I didn't have a cell phone back in the 90s. And he says, and he was originally he's a little snippy. He goes, so you got a certificate and you didn't get a check? I said, yeah. He goes, can you tell me whose signature is on that certificate? And I said, well, I don't remember whose name is on it, but let me walk up here. I laid the phone down and went up there where I had hung it on the wall in the customer's lounge where they wanted us to put all our stuff like that. And I came back and I said, Tom Wagner. And he says, oh. Then he dug around a little bit and he said, well, I tell you what happened. He said, we were sending out these checks for these Best Ideas contests for Service Life magazine. And apparently somebody got their hand in the till. And so we, in order to get their hands back out of the till, we're mailing the check as a separate mailing, not putting it with the plaque anymore. And so I said, okay. So anyway, I got the check a little bit later on. But anyway, that's the long and the short of that. Now this right here is what happens when you have a student that's putting a U-joint in and he's got something wrong and he doesn't know he's got something wrong. And he says, well, if I just keep applying pressure to this vise, it will press this U-joint in because it's got to move in an unstoppable force, an immovable object. And he winds up with the vise in two pieces. And this vise had been there a long time too. This kid busted this thing wide open. And it's really something what students can do. He wasn't a big, strong kid either, but I guess he knew how to use a cheater pipe, you know. But I don't know how many have ever seen this SDTP5 USA Snap-on. That is a spark tester that Snap-on made, and on the other side of it, it said not for electronic ignition. That's how old this thing is. Even though the handle looks fairly new, and this one here hadn't been used very much. You can see it's still got the thing on the end of it. But that thing has a little cell or a bulb or something in there. It didn't have any more wires hooked to it. But you could back probe the plug wire, and if you had spark there, that little thing would flash orange. And I had one of these in my toolbox for a while. I don't remember what happened to it, or somebody stole it or whatever. This is one they had at the school, and I was amazed to see that it was there. But it was nearly brand new and it had never been used. Let me know if you haven't seen one of those. You could also use it for a scratch-all if you wanted to, but it was designed to be a spark tester. SDTP5 is the number on that now. Well, until next time, that's about all I got for you. I hope that you didn't get bored to tears with all my tool stories. But I appreciate you guys watching, and I'll see you next time.